Okay, for 3-113, we have that Leon is standing 60 feet from a telephone pole. As he looks up, a red-tailed hawk lands on top of the pole. His angle of sight up to the bird is 22 degrees, and his eyes are 5.2 feet above the ground. Draw a detailed picture, label it with all the given information. How tall is the pole? Okay, so we've got the telephone pole, okay. And we've got Leon over here, and he's standing 60 feet from the telephone pole. Okay, as he looks up, a red-tailed hawk lands on top of the pole. So we've got the hawk. Up here, and his angle of sight is 22 degrees. So this angle is 22 degrees, the angle that he's looking up at the bird. His eyes are 5.2 feet above the ground. So to figure out the height of the telephone pole, we're going to use the slope ratio for 22 degrees. So slope of 22 degrees, this was one of the first angles that we did, is 2/5. You could also use your calculator and use the tangent button. Okay, 0.404. It's actually not exactly 2/5. This is a more accurate answer. So I'm going to put slope of 22 degrees equals the change in y. That's the change in y over the change in x. Change in y would be this length from the top of the pole to 5.2 feet above ground over the change in, why did I put x there? Let's put a y. That's the change in y over change in x is 60. Okay, so you could write slope of 22 degrees and use your calculator and figure out what that is. That's the tangent of 22 degrees. Tangent is just giving you the slope. Equals y over 60. You could just leave it like that and then cross multiply and divide. That would give me 1 times y is y. 60 times tangent of 22 degrees, and then just put that all in the calculator at once instead of doing it in separate steps and getting answers that are not as accurate as possible. So about 24 feet, so this is about 24 feet, plus we need to add this distance from his eyes to the ground, which is 5.2. So plus 5.2 would be about 29.2 feet. All right, for 3-114, write the equation of a line that has a slope, a 33.7 degree slope, and a y-intercept at 0.7. Assume the line has a positive slope. Okay. If the line, so it's a line and it's got a slope and a y-intercept, so we know it's going to be in slope-intercept form. If the slope is for the angle of 33.7, then I'm going to use that for the slope. And then the y-intercept is 0, 7. I'm going to use 7 for B. Remember, B is your y-intercept, or where you begin. M is the direction to move. Now, I'm not going to leave it like that. The slope of 33.7 degrees is the tangent of 33.7 degrees, which is 0.6. Why don't we round that off to 0.67? There's your answer. So kind of a nice connection to writing a linear equation. Okay. For 3-115, I know this is not the easiest drawing to do, but do your best. You've got parallel lines here. Remember, the arrows mean parallel. And it says to examine the triangles at right. Are they similar? If so, show how you know with a flow chart. If not, explain how you know they cannot be similar. Okay, so if my lines are parallel, then I know that two lines cut by a transversal are going to create angles that are the same. So these 4 angles are going to match these 4 angles. Now the ones I'm concerned about are the ones that are inside the triangle. So this angle and this angle are the two that I'm looking at. And if you were to take a sheet of tracing paper, trace that angle, slide it, translate it along the transversal, you can see that that's forming vertical angles. So I know those two angles are going to be equal. Okay, so I've got an angle equal to an angle, and I'm noticing that 4 corresponding to 6, if I look at that ratio, and I look at this ratio, 5, 7.5, those are the same. This is 2/3. This is 2/3. So I've got 2 sides in a triangle that are in proportion or proportional to these 2 sides. Whatever I'm doing to 4 to get 6, which is multiplying by 1.5, I'm doing the same thing to 5 to get 7.5. So I've got sides that are in proportion, and I've got the angle in between those sides that's congruent. That means that these 2 triangles are similar by side angle side. So we need to write a proof, a flowchart proof. So I'm going to start by saying angle BCA is congruent to angle, so BCA is right here, congruent to angle EDF. Now you could, if you put vertical angles here, I would be okay with that, but really we should put actually, if lines are parallel, alternate exterior, these are called alternate exterior angles, are congruent. Okay, and then we know that let's write it with letters, BC divided by ED is 4/6, which is 2/3. And then we know that CA divided by DF is 5/7.5, which also reduces to 2/3. Okay, so given these 3 pieces of evidence, we know that our triangles, triangle ABC is similar to triangle, let's see, ABC. If I name it that way, I'm going to have to say FEAB D. They are similar by side, angle side. That is a condition for similarity. Okay, 3-116 says to find the value of y if x is -3. So we're just doing a little substitution and simplifying. If x is -3, I would have -1/3 times -3. If it helps, you can put -3 over 1 minus 5. Okay, negative times negative, multiplication is first before subtraction. Negative times negative is a positive 1/3 times 3 over 1. Multiply numerator times numerator, denominator times denominator. So that's going to be positive 3 over 3, which is positive 1 minus 5 is -4. Okay, part B. If x is -3, I would have 2 times -3 squared minus 3 times -3 minus 2. Okay, order of operations, I need to do exponents. Okay, exponents, there's nothing in any parentheses, so that's why I'm not mentioning parentheses. But -3 squared is -3 times -3 is positive 9. I'm just going to bring everything down. Okay, I've got multiplication, I've got subtraction. I have to do multiplication before I do subtraction. So 2 times 9 is 18. Now here you could do this a variety of ways. You could just say 3 times -3 is -9, but then you need to remember to bring down that minus sign and think of it as 18 minus -9, or you could think of this as -3 times -3, which is positive 9. I did it in 2 steps. You can shorten that if you'd like. Minus a negative, subtracting a negative. Remember, subtraction is adding the opposites. So that's like adding the positive 9. 18 plus 9 is 27, minus 2 is 25. Okay, so if x is -3, we have 2 times -3 minus 5y equals 4. I'm going to solve for y, so I'm going to multiply 2 times -3, that's -6, minus 5y equals 4. Now, I like to have a positive coefficient for the variable that I'm solving for, so I like to do this. I like to do plus 5y and not have to worry about the negative. That's going to give me -6 equals 4 plus 5y. I know a lot of people are going to say just add 6 to both sides. That's fine, you can do that. Then I'm going to subtract 4. -6 minus 4 is -10. Divide both sides by 5. So y equals -2. Okay, for 3-117, in the interest of making a shorter video, well, I don't know, I'm a little nervous about making videos that are too long now that I've had a couple of them that I've had to redo. Let's see if this one will work. So for 3-117, it says you help out at the bowling alley on weekends. One of the arcade games has a bin filled with stuffed animals. A robotic arm randomly grabs a stuffed animal as a prize for the player. You are in charge of filling the bin. Part A, you're told that the probability of getting a stuffed giraffe today is 2 out of 5. If there's 28 giraffes in the bin, what's the total number of stuffed animals in the bin? Okay, so probability of getting a giraffe is 2 out of 5. And there are 28 giraffes in the bin. We want to know what's the total number of stuffed animals in the bin. Well, that means that there's 28 giraffes out of some total number of stuffed animals. So if the probability of getting a giraffe is 2 out of 5, 28 divided by something must reduce to 2 out of 5. So I'm just going to cross multiply. 28 times 5 is 140, equals 2x, and then divide both sides by 2, so x equals 70. Okay, part B, there must be 70 stuffed animals in the bin. The next weekend you see that the bin contains 22 unicorns, 8 gorillas, 13 striped fish, and 15 elephants. A shipment of stuffed whales arrives. What's the probability of getting a sea animal, whale or fish, if you add 17 whales to the bin? Express the probability as a percent. So percent is something we need to review. There were a lot of missed PSAT questions that were related to percent. So I'm going to look at this and say, well, if I'm figuring out the probability of getting some type of stuffed animal, I need to know the total number of animals. So I'm going to add 22 plus 8 plus 13 plus 15. Okay, those are the stuffed animals that we have, and then we have the whales. There's 17 whales. So if I do 22 plus 8, that's 30. Let's see, 13 plus 15 is 28, so that's 58 plus another 17. Let's see, 68 plus it would be 75. So there's 75 animals altogether, and we want to know what's the probability of getting a whale or a fish. Well, the probability of getting a whale, there's 17 whales out of 75 whales. Probability of getting a fish, there's 13 striped fish out of 75 fish. So the probability of getting a whale or a fish would be 17 plus 13 out of 75, so 30 out of 75. Okay, part C, you're told that the probability, express the probability as a percent. Let's review that. So 30 divided by 75 could be reduced. I know both of those are divisible by 15. 30 divided by 15 is 2. 15 divided by 75 divided by 15 is 5. 2 divided by 5 is 0.4 as a percent. I'm going to move my decimal point 2 places to the right, so that would be 40%. Percent's always out of 100, so it's like saying 2 out of 5 is how many out of 100. You could also think of it that way, if that makes more sense, and then just cross multiply and divide. Okay, part C. You are told that the probability of selecting a stuffed alligator needs to be 5%. One weekend you notice there's exactly 3 alligators left. How many total animals should be in the bin to maintain the probability of 5% for an alligator? Okay, so 5% is 5 out of 100, and you know there's 3 alligators left. So they want to keep the alligator probability at 5%. So okay, so I want to keep that probability at 5 over 100, but there's not 5 alligators out of 100 animals, there's 3 alligators. So I'm going to figure out what that total is. I'm going to say to myself 5 out of 100 is the same as 3 out of something. and then just cross multiply. So that gives me 5x equals 300. Divide both sides by 5, so x equals 60. So there must be 60 total animals. 3 out of 60. If you do 3 divided by 60, should come out to 5%, and that's 5% as a decimal. 5 divided by 100 is 0.05. Okay, this is a question that keeps coming up, and we really didn't quite get through all of this in the class that we explored this. It's actually a good e-tool. Anyway, two sides of a triangle have lengths 9 and 14. Now, I don't know what this triangle looks like. I just know two sides are 9 and 14. So if you think about it, what could the length of that third side be? If you put 9 and 14 together, if you lie those two sides next to each other flat, then the third side could not be 23. 9 plus 14, because then you wouldn't have a triangle. But if it was a little bit smaller than 23, you would have a very, very, very thin triangle. So the biggest that the side could be would be 22.9 or 22.999. So the upper limit for that side is 23. And then if you were to put, you want to say to yourself, okay, if the smallest side is the third side, not 9, let me draw this. Okay, so what plus 9 equals 14? If you have another side that you're adding to 9 and you're making a triangle, well, 9 plus 5 is 14. So if that third side was 5, then 14, you wouldn't be able to make a triangle with that. But if the side was a little bit less than 5, then you would again be able to have kind of a very thin triangle. So the third side has to be a little bit bigger than 5. So I'm going to say that this side has to be between 5 and 23, and that shortcut is you can just add those two together and subtract them to get the upper limit and the lower limit.